Meta did not just release another AI model. It crossed a threshold that turns machines from digital thinkers into physical actors. Inside Meta's research labs, engineers watched a robotic hand touch a fragile glass ornament. It did not crush it. It did not slip. It adjusted pressure the way a human would. That moment marked a shift in AI history. November 2, 2024 became the day robots learned to feel. Sparsh was the first tool. It learned touch without endless labeled datasets. Old robots needed humans to show them every single example. Sparsh learns like a real organism. It studied hundreds of thousands of tactile images. It built its own understanding of texture, pressure, and surface feedback. This let one robot learn from another even if their sensors were different. A universal language of touch. That had never been done before. Then came Digit 360, a fingertip with over 8 million touch sensors. Each tiny sensor, each tactile, picked up microscopic surface changes. Human skin cannot detect this level of detail. The fingertip processed touch locally. Reflex speed. Real-time reaction like muscle and nerve. Robots with this fingertip could sort fragile components in the dark. They could distinguish glass from crystal. They could feel the difference between metal smoothness and metal coated with oil. They could sense a trembling hand in a handshake and register nervousness. This was no longer a robot guessing. This was a robot feeling. Digit Plexus tied everything together, a synthetic nervous system. Multiple sensors across a robotic hand feeding into one unified perception channel. One cable to the robot's brain, not scattered data. Organized sensation. Reflex capable. Human inspired. Engineering refined. Manufacturing stood at attention. Factories in the United States and China faced labor shortages. Supply chains demanded precision. Robots always excelled at heavy tasks. They struggled with delicate assembly. That limit evaporated. These machines could now handle micro-components. They could assemble fragile electronics. They could grip pills without crushing them. They could rotate screws without stripping threads. Physical intelligence finally caught up to digital intelligence. Medicine saw another opportunity. Robots could assist surgeons with near-human tactile fidelity. They could sense tissue tension. They could navigate fragile vessels. A doctor could guide a machine with precision never seen before. Hospitals would not need fully autonomous surgical robots immediately. Assistance alone would change outcomes. Home robots moved closer to reality. A robot that can fold laundry without tearing fabric. A robot that can hand you a glass without dropping it. A robot that can wash dishes without smashing plates. Until now, those tasks remained out of reach not because robots could not see them, but because they could not feel them. The barrier between lab prototypes and real home use began to fall. The industry reacted fast. Competitors focused on language intelligence. Meta focused on physical intelligence. That strategic move blindsided them. They raced to respond. This was not about beating a benchmark. This was about who builds machines that interact with the real world first. Whoever wins that race shapes the next era of technology. Not the internet, not the smartphone, the physical world. Open sourcing changed everything. Meta did not keep the tools private. It released designs. It released data. It released code. That meant universities could build on it. Startups could build on it. Small labs could build on it. The same strategy that made PyTorch dominant now applied to robotics touch. Meta wanted to set the standard, and it might succeed. The world understood what happened. This was not hype. This was a capability shift. Robots could finally feel. The shockwaves hit Silicon Valley within hours. Google DeepMind held immediate meetings. Its vision language action models were strong, but without touch they were incomplete. A robot that sees but cannot feel cannot perform real tasks. It can simulate action. It cannot execute action with precision. DeepMind suddenly needed tactile intelligence. Microsoft and OpenAI faced the same realization. Language alone would not dominate the future. Intelligence needed hands. The AI race expanded from tokens and images into physical skill. Then came Meta's benchmark, Part NAR, a massive test environment for robots operating in simulated homes. 100,000 natural language tasks across 60 houses. Pick up the cup, fold the shirt, move the pillow, load the dishwasher, assist a human. The real target was not industrial robotics. The target was the home. The future AI assistant would not just answer questions. It would hand you a drink. It would clean a counter. It would help elderly people live independently. A digital assistant becomes a physical one. Factories saw timing. Supply chains demanded automation. Labor scarcity and rising wages pushed manufacturing to robotics. But delicate assembly always stayed human. Not anymore. Pharmaceutical packaging, microchip assembly, sensor installation. All tasks where a crushed component costs thousands. Robots with touch change cost structure. They do not tire. They do not shake. They repeat perfection. Economies shift when machines can feel. Partnerships proved this was real. Gelsight for sensor production. Warnick Robotics for robotic hands. Hardware ready, software ready, designs open, not theoretical, deployable. Early prototypes already running. Analysts predicted a new arms race. Not for language, not for images, for embodiment. Robots that move, robots that build, robots that assist. The next economy belongs to the companies that master physical intelligence. Meta chose a different battlefield and fired first. This did not end the digital race. It expanded it. Smart machines now had perception, reflex, texture intelligence. The line between biological touch and synthetic touch blurred. The age of embodied AI began with a fingertip. A single artificial sense ignited a global reaction. The future was no longer text on a screen. It was machines acting in the real world. The final question shifted. Not if robots will gain human-like touch, but how fast everyone else can catch up.